Um, Hello guys. So in this video, we're gonna talk about pointers. Probably it's gonna be my part one pointers video. So if you're interested in C programming in general or embedded systems specifically, you're gonna be interested in C pointers. Probably you have a background on what C pointers are. And if you don't have any background, I'm gonna go from the beginning, and we'll go into more depth through the videos. So okay, let's see. So we have like int x and int asterisk y. If you're familiar with programming languages in general or C specifically, you're gonna be familiar with most of what I just wrote. So int x is basically a variable of type integer, and int asterisk y is a pointer to type integer. So what's a pointer? A pointer is basically a variable whose value is the address of another of its type. So when I say int asterisk y, what I'm expecting is that y through the code is gonna have the address of another integer in my code. So let's say something like int x equal 100 and int asterisk y equal end x. So what is end x? End x is referencing, or referencing isn't actually a C concept or definition. It's basically C++. Let's say end operator gets the address of that variable. So when we're talking about end x, so this whole end x is actually the address of x. Okay, so that's supposed to be simple. So let's take this and let's start working. So let's put this here. So I'm sorry for my handwriting, it's a bit or a lot bad. So assuming this is address on 10,001, and here x equals 100, or it's just 100, you know. In this part of the memory, the variable x is saved. Its address is 10,001 and it has the value 100. So as not to get confused, let's remove that and say what, between brackets x, just to know that this is x. So assume this is 0, 50. So and this is y. So the value that this carries is 10,001. So what does that mean? It means that y is normal variable, but its value is the address of another variable. So what does that mean? It means that it's normal variable, so we can add it, subtract it, do the normal operations. But pointers have restrictions on these operations. We'll get into that into another video. For now, what we need to know is that it is a normal variable and it has its location in the memory. It is allocated just like any variable, and that it has its specific size. So that gets us to another point. What's the size of pointer? So the size of pointer is basically the size of the address bus of the target. So if we're working on a 16-bit target, the size of pointer is gonna be 16 bits, which is 2 bytes. If we're working on 32-bit target, is gonna be 4 bytes or 32 bits, and so on. Okay, so let's go into another example, maybe make it more understandable how pointers work. So let's say after this line we have in z equal 2000, and then we say y equals and z. So what did we do here? We allocated, or by C definitions, we defined another variable called z, and its value is 2000. And now we got the address of z. This part here is just like this one here. Got the address of z and put it in y. That's another thing. When you are declaring or defining a pointer, you say int asterisk y or character asterisk p, like character asterisk p. This is p is a pointer to type character. But after that, when you're using the pointer, you with its address functionality, don't write anything because the compiler already knows it's a pointer. However, if we type x equals asterisk y, that's called dereferencing of y, meaning we no more use its address functionality, or using its value functionality. So we're dereferencing, we're getting what's in that reference or what's in that address, which is in this case the value of z, because y points to z. Okay, so let's get this here and like work them together, because I guess it's gonna be better. Okay, so in this case, let's say we have here 2000, which is z, and let's say this address is like this. Okay, so now y doesn't have this address, but rather it has this, because now y points to z, it doesn't point to x. That's after this step here. After this step, we basically get the value that y points to, and now y points to z because it has its address here, and put it in x. So after executing this line, line number 5, x will have the value 2000. Okay, does it sound right? Does it make you feel it's right? Okay, so let's go into another trick from the pointer tricks. Okay, so after this line, if there was another instruction like asterisk y, which is, again, we're dereferencing what y points to. So okay, let's get this into a little more depth. So when we say asterisk y, what's dereferencing? So we get the value that's here. Okay, that's bad. Let's make it in another color so it's obvious. So that's an address. We get this address and we look through the whole addresses in the memory and find where is that address. Then we find the address here, so it is here. And then we go look into the value that is in that address, which in our case is 2000. Okay, so another trick is because we can actually use a pointer to alter the value in the address it points to. So if we write let's make it something unique. So 1 2 3. So in this case, after executing this line here, what we're gonna have in Z, and I repeat in Z, no, so it's gonna be 1 2 3. So in that point, Z equals 1 2 3. So let's get into a little example. Okay, so here's our examples. I typed all this off screen, to be honest. It's just to demonstrate what I just told you. So if you're not really familiar with printf, I guess you'll need a more basic C programming, because at this point I'm assuming you know what is int x and know how printf works. And anyway, I'll debrief you about how it works. So printf takes a string, and when it sees something, the percentage sign, what's after it tells it about the type it's gonna print and replace it. So when it comes here, it replaces all the percentage d thing with the thing after the comma here. So here we're gonna print that line according to what we learned here. That will be the value. That's more like it. So here we're gonna print the value of x, and here we're gonna print the address of x. Like we said, it's AND is an operator that gets the address where this variable is stored. And then here we're gonna do actually something we didn't talk about here, or we did. Like we said, the pointer is a variable in itself, and it is allocated in a certain address in the memory. So here and y, actually this operator to any variable, pointer or not pointer, it gets the address where it is stored. So here we're gonna see the address where y as a variable, not as a pointer, is stored. Then here we're gonna see the value it points to, which is should be exactly identical to the address of x here. And here we're dereferencing it, so we're getting the value where this address points, which is the value of x. So this is the odd one out. This should be equivalent to this, and this should be equivalent to this. Let's try it out, okay? And voila. So this is equivalent to this, and this is equivalent to this, and this is different because this is the address where y is stored. So we're gonna get into more examples in later videos. Thank you guys for watching. If you have any special requests, if you have any question, please leave a comment. Thank you.